Turn the lights.
Tēnā koutou katoa. I'm Paul Hulse, General Manager for Integrated Catchment Management at Environment Southland. I'll be hosting the webinar today. With me is Environment Southland's Chief Executive, Wilma Falconer, and Simon Hunt from Environmental Health and Support, the international consultancy that reviewed contamination data presented by New Zealand Aluminium Smelters at the Tiwai Point site. The webinar will start with introductory remarks from Wilma, and then Simon will give a 20-minute presentation on the report we commissioned from him. There is a Q&A button at the bottom of your Zoom screen where you can type in any questions you may have. I will put these questions to Wilma and Simon at the end of the presentation. EHS's full report and other material is available on our website. You will have already seen our embargoed media releases, highlighting the main points of findings and the Council's requirements of NZAS. If you have any other questions after the webinar is finished, please email them through. The details are at the bottom of the media releases. I'll now hand over to Environment Southland's Chief Executive, Wilma Falconer.
Thanks, Paul. Kia ora. I'm Wilma Falconer. I'm the Chief Executive at Environment Southland. Last year, Environment Southland engaged in a program to identify the degree and impact of contamination at Tiwai Point. The investigation included analysing the detailed site investigation report released by New Zealand Aluminium Smelters to us in late 2021. We engaged EHS Support, a consultancy with international experience in smelters, to examine the report and its data. EHS's assessment was completed a few months ago, and we have been giving it due consideration. We've shared the assessment and our follow-up requests of NZAS with the Minister for the Environment, with NZAS itself, and with a group of key regulatory agencies and iwi representatives. The assessment notes there are numerous legacy and ongoing sources of contamination to the environment from the Tiwai site. And our consultant's advice is that over time, a significant mass of contamination has been released into the environment. However, there are gaps in the data, and we're yet to understand the full extent of the contamination on the site, particularly in relation to the landfill, the SCL Pad, and the surrounding environment, specifically the coastal marine area and groundwater. The data we do have reveals a range of pollutants across the site, and we understand that some of the contaminant concentrations are above various risk criteria at the site surface, and they do require further investigation. New Zealand Aluminium Smelters has been working cooperatively and closely with Council over the past 12 months, providing access to the site and sharing their data, including the data in this report. And they have been contributing to our ongoing work program. In the last 6 months, we have been meeting regularly with New Zealand Aluminium Smelters to address the matters that have been arisen in the DSI report, and we've been working with them on the specific requirements that we have of them across this time. Most recently, we requested that New Zealand Aluminium Smelters prepare a waste stream management plan that outlines their process in detail for effectively managing contaminant waste at the site. As well, we're working with NZAS on an expanded contaminant monitoring program. And we are also embarking on an independent monitoring program in the coastal marine area. With any industrial operation of this magnitude, some level of contamination at the site is to be expected. But from the information we have, it's clear that for New Zealand Aluminium Smelters to continue its operation and remediate the site effectively, Tiwai needs to be managed in a more integrated way. And we are currently working through the most appropriate regulatory response to this. What is essential is that the way that the site is monitored and managed now and into the future directly addresses the expectation of the community and ensures that the adverse effects in the environment on the site and its surrounding area are mitigated. I'd like to introduce you to Simon Hunt, our consultant from EHS Support, and ask him to run through his findings and his advice to us, having analysed the DSI data. Simon.
Kia ora. Like Wilma said, my name's Simon Hunt. I'm from a consultancy-based EHS support that's based in New Zealand, but operates in United States and Australia. So I'm just going to share my screen with you to take you through a presentation. Oh, hang on. Oh, please. Here we go. So this is a presentation that we have put together for Environment Southland. This presentation, like Wilma said, has been delivered to a number of stakeholders already. And the presentation runs for about 15 minutes and really just takes you through the high-level findings from the work that we've done, looking at the information that's been supplied in the GHD report that was commissioned by NZAS and that was posted on their website last year. Contained in this presentation are other pieces of information that are also up on their website regarding environmental monitoring they've been doing on some of the various parts of the smelter site. So the first slide really just explains a little bit about EHS support. Like I said, we're an environmental consultancy. We principally operate in the United States with about 250 staff. We have a number of people in Australia, and we have a small number of people here in New Zealand. EHS support has actually been working on aluminium smelters for well over 10 years. We've worked on both refining and smelting sites in a number of different countries, kind of listed on the slide here. And we've worked on approximately 20 plus smelting sites around the world. We're very much sought out by different parts of the aluminium industry to help them with different issues. And we've recently been working on some toxicology type work for an organization in the States to do with fluoride. Listed there is the typical kind of work that we undertake on smelter sites. And there's a range of environmental issues ranging from investigating sites, very much like what GHD's just done for NZAS, right through to the oversight of the facility decommissioning. So that provides a little bit of background to EHS support. This is just a slide about myself, so you kind of gain a little bit of context about me. I'm an environmental professional with over 30 years of international experience. I've got a degree in geology and a master's in environmental technology out of the UK in the 1980s, which probably places my age a little bit. I've worked both as a consultant internationally, and also I worked for a major oil company, Chevron and Caltex, for quite a long time, based here in New Zealand, working through Asia Pacific. By background, by training, I'm actually a chartered geologist and a certified environmental practitioner, are kind of my professional accreditations. Since I've been in New Zealand, I've been here since about 1993. I've been intimately involved in writing guidance and policy on contaminated sites for various local and central government agencies. And I've worked internationally and in New Zealand on a significant number of very large chemical and manufacturing facilities and also toxic waste disposal sites. So that gives a little bit of background to me, which hopefully provides some context on how I can talk to some of the issues that we're seeing on the Tiwai smelter site. For those that don't know it, this is just a map or a plan taken out of one of the NZAS documents, but the DSI that was commissioned, this detailed site investigation, just focused purely on the smelter domain area, and that's the area that's kind of highlighted by that that circle there. But it's a big site. I mean, the smelter domain itself covers an area of about 92 hectares, which is a very large manufacturing plant. Obviously, the NZAS facility straddles this peninsula area. There's a couple of other areas that you should probably note. There's an area colored in purple, which is just down to the southwest of the smelter domain area, which is an area where there's all the different landfills where the waste is disposed of. And then obviously there's a small little red area down to the southeast, which is an area they called the SCL Pad, where there's a whole lot of historic waste materials stored currently. So the DSI is purely focused on this one area called the smelter domain. And that's going to be the principal area of my talk today. So the investigation objectives are quite clearly stated in the report for those people that have kind of have leafed through the report. But the aim of the investigation was to actually assess just the presence and risk of potential contaminant exposure pathways. And what they mean by exposure pathways is just the way that a particular type of contaminant that is in the ground or in the soil or the groundwater may migrate and actually impact receptors. They could be human health, people working on the site, people that are visiting the site, or it could be the environment. Another aim of the study was to actually understand what they call the spatial extent and depth of the contamination. That helps NZAS understand what the significance of that liability of what contamination is in the ground and helps them understand how they potentially need to remediate the site. The work they've undertaken helps NZAS understand what options they could possibly use as part of any future remediation of the site. And obviously, the information contained in that report obviously will guide and inform any implications of future resource consents that are needed for the ongoing operation of the site, or should the site close at some point. The report itself was kind of titled Detailed Site Investigation, and that term comes out of regulations and guidance that is used in the contaminated land arena within New Zealand, and is kind of stipulated in certain guidance that's put out by the Ministry for the Environment. Really, the report should have been retitled as an initial study, because again, whilst a vast amount of work was done, it's only an initial study of the actual contamination impact on the site. There's an accompanying document that wasn't released initially when we undertook that review of the detailed site investigation, and that's a report called the Preliminary Site Investigation. What the Preliminary Site Investigation details is really, it documents and collates all the historical information pertaining to the site, and then you use the information contained in that report that was kind of discovered to help you plan your detailed site investigation. So those two reports have been prepared by GHD for NZAS, and obviously we've reviewed both of these reports. In terms of the contaminant sources on the site, to the right is just a kind of pictorial of the smelter itself. But within the wider complex itself, there are kind of three areas where contamination kind of sits and arises as a consequence of the manufacturing operations. First is the smelter domain area, which is the main area of the talk today. There's the area of the landfill, which I've kind of referred to, and then there's this area of the SCL pad, the spent cell lining pad, where waste materials are stored. But if you take or consider the smelter domain itself, in terms of when contaminants get discharged to the receiving environment, the main pathway by which contaminants get discharged to the environment is really through the stormwater system. So if you look at that pictorial to the right, the bulk of the contamination that is leaving that site actually is draining out through the stormwater system. And the site really drains through three drains. One goes north, one goes west, and one goes to the south. But all of those drains discharge into the inner harbour area, just to the sort of northwest of the smelter. There are other areas or other mechanisms by which there are discharges to the environment. There are discharges to air that are discharged from the manufacturing process. And obviously, there are discharges into groundwater as contaminants leach into the groundwater system, or they leach out of those drains that are draining the stormwater out to the receiving environment. This next slide is a kind of pictorial, or like a cross section through the site. It's quite complicated, and I apologize for that, but it's a fairly complex facility. But what this, what they call a conceptual site model aims to do is work your way through the process of aluminium smelting, both from how the raw materials come into the site, how they're kind of used in the manufacturing process, and then the waste products that are generated as a consequence of that manufacturing process. And it kind of, at each stage, it identifies what are the key contaminants that are actually released or generated during that process. And so as professionals working in this field, we use these conceptual site models to kind of help us understand where contaminants are being generated and the likely mass or concentration of contaminants that are likely to occur in particular parts of the site. And that then helps us map out how the contaminants are going to be impacted or discharged into the receiving environment. So if you actually studied this plan here, you'll see that there's a range of different contaminants that are kind of generated at various stages during the process. And depending on how the facility is run and how the wastes are actually handled and managed on site, there could be potential releases to the environment, either to the surface water, to air, or into groundwater, or through waste that are actually buried in the landfills. This is a kind of an oblique aerial photograph, like Wilma said. The facility itself holds a large array of different discharge consents. Many of those consents have still got quite a few numbers of years to run, I think in the order of about 10, typically for some of the consents. The landfill consent is actually up for renewal at the end of next year. But obviously the facility has a number of discharge consents that were granted probably 15 odd years ago, and those consents are still running. And that's effectively how, but those are the regulations that control the operation on that facility. So there's a number of different discharge consents, all of which allow a certain volume or a certain mass of contaminant to be discharged out to the environment through the consenting process. The contaminants of concern, there's quite a range. There's a range of what they call trace elements, and some people often refer to those as heavy metals. There's some obvious ones in that kind of list of metals that are listed there. Aluminium is obviously one of the obvious ones because that's the raw material, the alumina that is being used in the manufacturing process. But obviously, depending on where the source material is derived, there's a number of other trace elements that kind of come along with that alumina, which again can get released into the receiving environment during the manufacturing process. A range of different hydrocarbons are used in the process. There's obviously fuel, diesel, there's pitch used in the manufacturing process, and other hydrocarbons. All of these hydrocarbons have different chemistries, contain different particular contaminants, and again, they get released into the environment. Fluoride is one of the most common contaminants on a smelter. It's highly soluble, and it's probably the biggest in terms of mass of contaminant that is actually released to the environment through that manufacturing process. Obviously, the smelting process uses a vast amount of electricity. And in the old days, a lot of those transformers that are used in that electrical process had heat transfer oils obviously in the transformers, but historically they would have had contaminants called polychlorinated biphenyls actually in that oil. So again, those transformers would fail. Obviously, it's just part of a manufacturing process. You know, things do break, and so occasionally there would have been releases of those oils to the environment. And again, some of those historical oils would have contained these contaminants called polychlorinated biphenyls, which are very incalcitrant compounds that they hang around in the environment for a long time, basically. And then obviously cyanide is generated as a byproduct from the manufacturing process. And obviously the manufacturing process itself, there's a lot of heat involved in there. So historically, there's been a wide use of asbestos throughout the whole of the site. So there's a very large cocktail of different sorts of contaminants that are going to be present at different parts of the manufacturing process. So the key findings from the detailed site investigation was obviously, like Wilma said, this is a site that's been around since the 1960s. There is widespread soil contamination across the site, which is kind of typical for a manufacturing plant. But we were surprised to see quite high levels of fluoride just in the surface soils in parts of the site, which suggests that certain types of waste have just been laid down on those soils at some point during the operating process. There's a significant amount of groundwater contamination sitting under the site from fluorides, these polycyclic aromatic hydrocarbons that are in the pitch, and obviously aluminium. And those are all key contaminants that are kind of generated or used during the manufacturing process. And obviously, like I said in one of the earlier slides, stormwater is the main mechanism by which contaminants are released to the environment. And there's probably no surprise that there's high levels of aluminium, arsenic, these polycyclic aromatic hydrocarbons, and fluoride in the sediment in the drains. The study that was undertaken by GHD, whilst it's comprehensive in terms of its size and probably the cost, obviously it's an initial study, and obviously there are some contaminants that to us were quite, what we kind of said were conspicuous by their absence, in that the investigation probably just didn't look for some of these contaminants, such as these PCBs that I spoke about previously. There's some issues in terms of some of the test methods that were used around cyanide testing that isn't readily available in New Zealand. And some of those trace elements in the alumina source material weren't necessarily looked for. And again, it was an initial study, but obviously some of these things would need to get picked up in future studies that are undertaken on the site. Just in very, very simple terms, in terms of how this contamination, once it gets into the soil, these contaminants will potentially leach into the groundwater system. The geology on the smelter site area, the peninsula, is really quite simple. It really has pea gravel, which is what you see down to that photograph on the slide, is a very coarse grain material overlying a finer sand material. There's shallow groundwater sitting in the pea gravel and the fine sand below the site, and obviously that groundwater discharges really to the north and northwest and to the south into Foveaux Strait and into the inner harbour. So any contaminants that leach out into that groundwater system will migrate over time into the receiving environment. And obviously there are a whole lot of kind of physical and chemical processes that kind of change those contaminant concentrations. But that's the general process that kind of works, you know, simply on this site. Whilst the geology looks simple, there are some complications. When the site was originally built, we understand that there was a fairly kind of low-lying swampy area through the middle of the site. So that we understand that area was excavated and other materials brought in, probably pre-metal to backfill that void. So again, this kind of changes the geology a little bit in that area. And again, it will influence how the contaminants in the groundwater system flows through the site. And obviously from a sort of geomorphology perspective, this is the whole peninsula consists of a whole lot of beach ridges, which kind of are aligned east-west, which again will influence the groundwater flow on the site. So whilst the geology may look simple, we're anticipating there are some complexities that will influence the flow and the direction of groundwater flow, in particular issues around tidal fluctuation, and obviously there are issues out there in terms of just sea level rise and erosion of the peninsula area, which all have a potential effect on the site and the groundwater flow and the contamination. In terms of how groundwater is flowing, these two diagrams are taken out of different reports. The one to the right on the smelter domain is taken out of the GHD report that shows groundwater really flowing through the smelter domain out to the west and the north-northwest. Again, these are only provisional plans at the moment. There's more work needed to understand the direction of groundwater flow and also the influence of tide on how that alters the groundwater flow direction. The groundwater flow on the landfill area is obviously a bit more straightforward. There's a groundwater, what they call a groundwater divide, that runs through the middle of that peninsula area. So you're going to have some groundwater flow to the north into the inner harbour, but the bulk of the flow goes out into Foveaux Strait. In terms of the contamination, what we did here, we took the GHD data and just compared that data with ecological criteria, just to kind of get an appreciation of where the kind of mass of contaminant was and how that related to ecological risk criteria, just in terms of the soil and the sediment on the site. And what these little basically dots or figures on this plan show, the different colors represent the different contaminants, and the size of the or the shape of the dot basically just shows you the increase above a kind of risk screening criteria for ecological risk in terms of the contaminant concentration. And obviously what it's showing is that there's the sort of the dark green sort of colors are really showing where these polycyclic aromatic hydrocarbons are, and they're all over generally the west area of the site principally, and that's principally where the pitch is used in the manufacturing process. So it's no surprise that we're seeing those types of contaminants in that area. The kind of off yellow color is the fluoride, and obviously there's an area just south of what we call the pot lines of those buildings that are kind of rectangular in shape in the middle of that picture. And so just to the south of that is an area called the Inalco area, which is a laydown area for a lot of the spent pot liners that come out of the facility. So again, we're seeing high levels of fluoride in the soils in there. And then there's nickel above ecological risk criteria over a lot of the site, and that's just believed to be a byproduct from the actual alumina. And then the next slide really just gives you an indication of the sediment concentrations in the stormwater drains that are on the site. These are concentrations taken out of the GHD report. And again, what we see, which is high levels of alumina in the sediment in the stormwater drains, and much of that alumina within the drains within the site is obviously above typical criteria that would perhaps be a screening criteria for ecological risk. And again, as that sediment travels out through those drains, then it does get diluted before it goes out into the receiving environment. Part of it, like Wilma said, part of what Environment Southland wants to progress is to gain a greater understanding of the impact out in the receiving environment. And this is just an aerial photograph showing some of the proposed sampling areas that we're potentially going to be looking at on the different drains that discharge into the inner harbour. So it's just being used to kind of communicate to NZAS. This is the kind of scale of initial environmental monitoring that is being proposed both for sediment and surface water that is discharging out to those receiving environments to assist Environment Southland with their work in terms of managing the effects on the environment. The last couple of slides in the presentation focus on the landfill area and the SCL pad. The landfill area, like I said, is just down to the southwest of the site. The consent on the landfill expires at the end of next year. NZAS is what they've they've communicated they've shut the gate on the landfill site, so they're not taking any more waste into the landfill site, and they've got a significant program of work coming up to basically apply for a consent for a closed landfill consent in the future. But what we are seeing across the landfill area is there's quite a large area of flux of fluoride contamination entering into FOVO Strait, and this information is taken out of an NZAS report that's up on their website. And then the SCL Pad is, like I showed in that original picture, and it's just down there on the left of this slide, is quite distant from the main smelter complex, but it's an area where there's a whole lot of historic waste that's been encapsulated on a pad down there for storage purposes. But again, originally, when that material was first stored, there were quite high levels of groundwater contamination discharging out into FOVO Strait. NZAS has continued to monitor that groundwater contamination over the years. One of the plots here dates from like 1995, showing quite high levels of contamination. And again, over a period of time, this contamination has kind of declined, but there's still a flux or a discharge of contamination into FOVO Strait. So I think that is the, oh, there we go, one last slide. So the key data gaps that we have at the moment, this is kind of emphasized in the report that we undertook or prepared for Environment Southland, is that there's a lot of historic data on this site. I mean, the site itself is almost rich in environmental data, and to enable Environment Southland to do its job in terms of understanding the effects on the environment, that data kind of needs to be processed and collated and assessed to help build a conceptual model in terms of where and how the site has operated, where there's been activities, where there's been losses to the environment to particular contaminants, to help build up a picture historically of how the site's been operated and where we anticipate contamination could be located. And then having built that conceptual site model, you then use the information, say, that GHD has generated an additional investigation to kind of test that model to help you understand where the contamination is and understand the picture that it's actually painting in terms of how the contamination exists in the environment, how it's moving out into the receiving environment. So the key data gaps that are kind of sitting there at the moment is there's further investigation needed within the smelter domain. I understand that NZAS has got that planned. There's a program of work really to understand what the aquatic receiving environment looks like in terms of potential effects, and Wilma's kind of alluded to that there. There's more work needed on the landfill and SCL Pad area to understand the nature and the extent of the contamination there. And again, in terms of assessing the contamination, a key part of that process is to understand what the actual risk is. So these contaminants will pose different risks to different receptors, whether it's human health or the ecology, fish or shellfish out in the harbour. So there's a whole program of work needed to understand what these actual risks are, because a lot of the criteria that are used by professionals to screen the risk from contaminants, there's screening levels that just signal or notify that you need to do more work to understand the risk. And this is what's captured in these last bullet points, really, that there's more work to be done understanding what these risks actually pose, both to the receiving environment and to people who will potentially use the site in the long term. So that, I think, concludes the presentation.
Okay, Simon, I'll just give you a second to stop sharing.
Cool, thank you.
Well, what we'll do now, we'll move into the question and answer session. So I'll just start to read out the questions. I think the first one is for Simon. Does the community who's drinking the groundwater need to be worried?
To the best of my knowledge, the community doesn't use the groundwater. I know NZAS uses, they take groundwater further out on the peninsula for their own purposes. So I don't think there's any concern there. I don't believe there's any use of the groundwater from a potable sense within the site.
Okay, next question again for Simon. Because the data doesn't tell us whether this is causing negative effects to the land, groundwater and the coastal marine environments, what work will be done to determine this?
Well, that's the work that I think we've just touched on there, and I think Wilma's alluded to, is that there needs to be work done both within the inner harbour and FOVO Strait to actually understand the effects where this contamination is actually discharging. So there's a whole program of work that's been planned, it's been discussed with Environment Southland, and that information is being shared with NZAS, and that was the independent work that Wilma referred to, that will basically go out and actually start to assess the contamination, or try and assess the contamination in those areas to understand what the concentrations are. And once you've done that, you can then start to understand whether or not that contamination actually does pose a risk to the receiving environment.
Yeah, so I can also add to that. When I mentioned that we're working closely with New Zealand Aluminium Smelters on a monitoring, an enhanced monitoring program, they've got an extensive network of wells on the peninsula, and they have now lodged with us a consent to drill an additional 45 bores to help us identify more information on the site. And we've discussed that with them. We've also asked them to drill a further 7 monitoring wells in the areas that we're interested in actually seeing the data for. And yes, as Simon mentioned, and I mentioned earlier, we've got a program that we're about to embark on to do some independent monitoring in the coastal marine area around the site to look at the environmental impacts that may be occurring there. We need to look at what impact the contamination is having on that coastal marine area. It is highly dispersed area. It's a coastal area, so the contamination is dispersed easily. We also have been working with NZAS to extend the kinds of tests and to better understand the hydrogeology on the site. So that work is working collaboratively with them at the moment.
Another question for Simon. Can you please explain in simple terms for those people who don't know the various ways in how this contamination has occurred?
Well, I mean, you have a manufacturing process that uses a whole lot of raw materials, and those raw materials get brought in primarily, but by ship onto the site. All the way through that process, and generally over time, with any industrial operation, improvements are made, sequentially as those operations kind of work through many years of operation. So in the early days, management practices were probably quite lax. Again, there would have been losses to ground during those processes. And again, a lot of the contamination that we're practicing in the groundwater, again, is historic contamination. And so what happens is that you end up with losses of contaminants to ground during the receipt of the raw products, during the processing, during the transfer of the products within the site, during air discharges. So these contaminants kind of build up within the site, within the soil, depending upon the kind of chemical characteristics of those particular contaminants. Then some will leach more readily into the environment. So if we look at fluoride, for argument's sake, it's a highly soluble contaminant. So again, we see high concentrations of fluoride in the groundwater because it is a more soluble contaminant. Some of those polycyclic aromatic hydrocarbons are very recalcitrant. They're not particularly soluble. So you don't see particularly high levels of some of those contaminants in the groundwater because they're just not soluble. What tends to happen to those contaminants is they tend to stick to the sediment. And obviously the sediment gets washed out into the stormwater drain, and the stormwater drain then discharges out to the receiving environment. So there's different mechanisms on how this contamination moves within the site. And obviously, the task that GHD has had working for NZAS, just like the task that we have, is trying to understand the mechanisms by which these contaminants potentially move within the site and within the environment that enables them to kind of discharge out to the receiving environment. And obviously the next part of the puzzle is to understand exactly whether or not these contaminants are actually accumulating at sufficient concentration out in the receiving environment that they could actually pose a risk. And that's obviously the work that Wilma's referenced that, that will get done out in the receiving environment in that coastal marine area.
Okay. Environment Southland have been monitoring this site. Why was it not aware of the level of contamination? Perhaps Wilma can answer that one.
Sure. So to understand how the site is being managed is part of the historic nature of managing under the existing tools that existed for us in a regulatory way. So we've been managing that site as a result of historical consents. There are 8 consents, as Simon mentioned, on that site. They relate to very specific points on the site, from points of discharge to groundwater and to air. And it's fair to say that those consents, some of which are 20 to 30 years old, are products of their time. And so the monitoring information that's provided to us by NZAS as part of that consent process relate to those very specific sites. What this information has done for us, being able to get access to broader information on the site, has been to be able to see the impact across the site as a whole. And we don't monitor the whole of the site. Those monitoring wells that exist on that site are New Zealand Aluminium Smelter's monitoring information, which they were not obliged to share with us under the existing consents. And that's why looking at managing the future of this site, we're looking at a more nuanced and a much more sophisticated regulatory response than the past.
A question for Simon. Which of the contaminants is the most risk to human health or the environment?
Well, there's a range of contaminants that are on the site, and obviously, if we ran through them, off the top of my head, you're dealing with fluoride is probably the biggest massive contaminant that is discharged, but it's probably the least. I mean, they're all going to pose, depending on the nature of the receptor, they will all pose different sorts of impacts at different concentrations. But even though fluoride is probably the biggest massive contaminant released relative to the key contaminants on the site, it's probably the one that's going to pose the least amount of problems. I mean, your contaminants, such as some of your polycyclic aromatic hydrocarbons that are really quite recalcitrant, are probably some of the ones that would probably pose, the greatest risk, to people. Well, primarily the receiving environment, to be quite honest.
Question for Wilma. Is the situation worse than expected? And does this change the expected cost to clean up and restore the site?
So, this is a large industrial site, so we expected to see contamination on that site. What this information and Simon's analysis of it has helped us understand is the scale of it across the whole site, and the nature of that contamination and how it might be managed in the future. The costs, the other part of the question was...
just one sec.
Was about cost, I think.
Yeah, and does this change the expected cost to clean up and restore the site?
So the remediation plan that New Zealand Aluminium Smelters has released in its preliminary closure study, they put a dollar figure on that. Their dollar figure is probably a reasonable assessment of cost, excluding the cost of cleaning up their landfill area. So they were talking something in the vicinity of $700 million. And I think that between that and potentially $1 billion to clean that site up was a reasonable estimate.
Simon, can you tell if the amount of contaminants has reduced in recent years, or is the contamination continuing at a high level?
Well, within the smelter complex itself, we don't have line of sight on how the contamination has kind of changed with time, and that's obviously some of the information that we're kind of trying to extract, or would like NZAS to supply us with. Certainly, if you look at some of the plots that they provided to us, and some of those plots are just up on their website at the moment, is that in the area of, say, the SCL Pad, then yes, the contaminant concentrations have declined with time, and that in part is because the SCL Pad area, they had some problems early on in the piece, I understand, in terms of the construction or fabrication of the storage facility, and that resulted in high levels of groundwater contamination. And obviously over time that has now kind of declined, but again there's still an ongoing discharge, albeit a lower concentration than what it was in say 1995, which is the data that we have. The same with the landfills. There's data going back probably 10-20 years that shows really quite high levels of contamination, but obviously that has reduced with time. But again, just the whole process of potentially remediating the landfills and managing the landfills that now that they're kind of closed and that they're moving into another stage, again that process needs to be handled very, very carefully, because again you can liberate contamination during the process of trying to clean a site up or cap a site, or depending on how you're actually going to manage it. So again, that it's a big area in terms of that landfill, and it needs to be managed well. Otherwise, that declining contamination that you're seeing will bounce back up, because you'll disturb the contaminants again, basically. So,
okay, Simon, another question for you. What sort of impact do PCBs have on people or the environment?
I mean, basically, if there are PCBs on the site, and if they have been released out into the environment, they'll be principally stuck to the sediment, and depending upon the concentration, that they could potentially be taken up by different organisms out in the receiving environment, whether they're fish or shellfish sort of thing. And again, if people were to consume those and there was PCB contamination, then there could be a potential risk. And again, part and parcel of the work we're doing that's being proposed for Environment Southland is to understand whether or not there is actually a risk or not. So at the moment, no one knows whether there is a potential risk, so.
How long will it take to complete the further work to understand what effects this contamination is having on the environment? When will we know the full extent of this contamination? I think probably Simon, if you could. Was that a question more around the smelter complex or out the receiving environment? Was it the receiving environment?
It's the receiving environment, I think, Simon, in terms of the coastal marine work done?
Yeah, well, the initial plan at the moment, there's probably a program of probably 6 to 12 months worth of work. And then obviously during that process, you'll be reporting back to Environment Southland. So the initial program of work was probably going to run for about 6 months, just in terms of the data collection, data analysis, and then obviously there's reporting on top of that. So again, you know, you could be 6 to 12 months away from really understanding what the potential risks are. But again, you know, you can do that work, you know, and again, you'll be getting information come back. Any investigation, like even like the you know, the DSI that's being completed by GHD, any investigation is kind of is an iterative process. So again, you're just gathering more information, and as you step your way and work your way through the investigation, basically. So there will be the ability to provide initial information back to Environment Southland as that data is collected, basically. So.
Okay, I don't have any more questions at the moment. I'll just give it a moment, just in case there's any last minute questions. Yeah, no more questions. Oh, one more just come through. Oh no, yeah. I suspect that's probably ended the question and answer session. So perhaps I'll pass back to Wilma to, oh no, one more question has come in. How does this compare to other sites? Simon?
Dealing with my colleagues in other, you know, other jurisdictions, both Australia and the States, I mean, the contamination levels are pretty similar to what they see on other sites. I mean, some of the information I've looked at on some of the sites in Australia and the States, again, have similar levels of contamination, and often it's just a function of the size of the site, what the geology is as well, in terms of the kind of the variation. But again, you know, we're seeing other sites I've looked at, and reports I've reviewed and dialogue I've had with colleagues, you know, in other parts of the world, is that yes, we're dealing with, you know, almost identical kind of scale of problems, and it's just reflective of the nature of the receiving environment, the type of geology, the depth to groundwater, on whether or not, you know, those contaminations are any higher or lower, basically. So, you know, it's a similar process, and often it's just reflective of the age of the facility, basically. So.
Another question just come through. Does Environment Southland plan to warn people of the possibility of contamination and the possible health risks in the coastal marine area? Bearing in mind you intend to monitor those areas.
So we intend to release information as we have it. So whatever our findings are from, so this is the first release of the information that we've been analysing. We will be releasing information in an ongoing fashion.
I don't have any more questions at the moment. I'll again pause just to see if any more come through.
So Paul, if there are no more questions, I'd just like to say in summary that, you know, the purpose of the work that we're doing is it's ongoing. We're looking at information as we get it. We're working through an enhanced program of monitoring with New Zealand aluminium smelters. And as we said, we're looking at our own independent view of the impacts of the marine environment. This information is essential to us in being able to understand the nature of the way the site operates and the effects of contamination in terms of their impacts on the environment is the next piece of work that we're undertaking. So we'll keep you informed as that information comes to hand, and thank you for your time.
Okay, I think we can then close the webinar. Thank you for your attendance.